Good morning and welcome to our webinar. My name is George Lamb with Nextivity. That's who do I work for, Nextivity. And we're going to get started on indoor coverage for the Middleprise. Now, of course, as usual, I'm not going to do all the work. I want to introduce you to Joe Smeltzer, our head of product. Joe's the one that's going to be taking us through our presentation. Joe, what I'm going to do is just sneak off and go in the next room, and I will look for questions and answers and kind of manage the interaction with the rest of the folks. If it's okay with you, every once in a while I might interrupt you.
Perfect.
And say, hey, can you help us out with this question?
Perfect.
Okay.
Yeah, prefer the Q&A to the lecture.
Absolutely.
So.
Okay. I'll pop back in every once in a while.
All right.
Okay.
Great.
Welcome.
Great. All right. Let's get this going here. All right. So let's go. Today I'm going to be talking about the Middleprise and the Cel-Fi QUATRA, and we'll touch on a few other things. I am Joe Smeltzer. I'm, as George said, I'm part of products here. So we'll just, with no further ado, we'll continue. Okay, so started to talk a little bit about who is Nextivity. Many of you are new to this, new to us, new to our products. Our company was founded in 2006. We have headquarters in San Diego, California. Our offices throughout the U.S., also in Spain, UK, Israel, Singapore, lots of support in different places globally. We've been approved for use on nearly 200 mobile operator networks globally. We have an aggressive R&D program, which is constantly generating and advancing our IP portfolio. If you work with us, you'll see a lot of innovation, a lot of new stuff. We invite all of you to our office here in San Diego for a tour. Happy to show you our labs and meet some of our people, and we'll go from there. Okay, so what is CelFi? I'm going to spend a little time on this one. CelFi is, for us, everything starts with our chipset. We build our own chipset. We're one of the few companies in this space that does that. You would spend $10,000 to get an FPGA with equivalent functionality to our chipset. That's what we spend when we're trying to simulate it, and we have to buy an FPGA. Our chipset, well, why do we do it? Our chipset enables us to digitize RF incredibly fast and convert it back to analog at latencies so small that they're undetected by the 4G network. And that's very important. That's part of our network safe mantra. Today we're shipping our third generation chipset, which we call Aries, and we're getting ready to commercialize our fourth generation. It's already back from the fab. Our fourth generation chipset will add TDD to our capabilities and also sets the stage for us for 5G. Coming up from the chipset is our embedded software. Our embedded software drives our system. Because we're building our chips, we cannot rely on code from third parties. We have hundreds of thousands of lines of code that we've developed over the years. Our embedded software runs things like our AGC, our auto gain control, which we can do so fast. We can deploy 100 dB gain systems actually in mobile environments like trains or other vehicles. We handle our echo cancellation in our embedded software, which is done so well we can apply a positive gain margin to our systems. That gives us a bigger footprint that makes the system perform better. And it gives a better user experience. It all comes through on the ground with our systems. Radio design. We build our own radios. We do everything from 600 megahertz to 2700 megahertz. We cover all the FDD bands globally. We ship our stuff globally. We're in the process of adding TDD to our portfolio. We also develop 5 gig radios in the unlicensed spectrum. We use that spectrum for our proprietary protocol in our 2-box systems, which are some of our best sellers. You may have heard of our Pro or Duo products, which are also shipping globally here for a long time. We built our own BQB certified Bluetooth module using TI chipset. We've been shipping that now for a couple years. And it's been iterated a couple times. So we have a lot of radio experience, and we'll continue to grow that part of our portfolio. We do our own antennas. We build our antennas to support all of our systems. They support our radios. We do a lot of passive PCB style internal antennas. We also develop external antennas. We have some partnerships that we, for some of the antenna designs that are where they can add value, we can add value. Towards the end of the year, you're going to see some additional innovations from us in the marketplace around the antenna. We're super excited about that. Stand by. And then finally, mechanical design. This is where the physical product all comes together. We have an in-house mechanical design team, continues to grow. We do all of our mechanical designs here, everything from heat sinks to our enclosures, to our mounting brackets, covers, and of course the plastics themselves and everything else. So we have a very thorough and comprehensive design team here in San Diego. Our cloud. So we built our first cloud in 2014 with a well-known, small at the time, IoT company. They were acquired. So we immediately started work on our second cloud. We've been building that now for about 2 years. We've been commercial. Our cloud is built on top of Microsoft's Azure IoT platform that gives us carrier-grade security and global scale, which is important for us. As I mentioned, we're touching customers globally. We have relationships with 200 network operators and growing. So very important that we have global scale and carrier-grade security, and that's what our Wave Cloud gives us. We also have NMS capability, network management systems. You hear a lot about that, particularly in this category of product. The Middleprise product or the DAS style products, NMS is critical. We have full NMS capability. We can do things like alerts and alarms, and many other things that I'll talk about a little bit more later with our cloud. It's pretty awesome. We do mobile apps. We have mobile apps for Android and iOS. We've deployed in China. We have apps on Tencent, desktop, web-based tools, the whole 9 yards. We've got a full app software development team that does a lot of work for our partners and for our customers. Okay, so what are our value propositions? That was sort of the guts of what CelFi is. This is the value proposition part. So what are we? We're best in performance. We're 1,000 times stronger than our competitor. And this will come up a few times. We are 100 dB of gain. We have systems that are essentially 30 dB stronger than the nearest competitor. 30 dB is a huge amount. That's a number you'll hear throughout this presentation. It's important. 30 dB is huge. Makes a big difference in actual footprint. It's not academic. It's important. It's night and day in terms of user experience. We're the lowest TCO. So bigger footprint means less equipment. It means more performance assurance. It means a better customer experience. And you can get all of that with less cost, less truck rolls, less time install, less time doing maintenance, less time fixing problems. Ease of setup is a key pillar of our core here at Nextivity. It's in our DNA. Our competitors produce systems that have multiple people to install. You have walkie-talkies, ladders, serious tools. Our products are plug and play. Even in the DAS category, which is, of course, very complicated, very expensive, it requires a high level of skill for setup and commissioning for many of these systems. Our stuff is absolutely simple. You'll hear more about that. Network safe, of course. We don't build products that aren't network safe. Our mantra is 10 plus years of selling to and through the carriers. We won't put something into the market that a carrier wouldn't be comfortable deploying on their network with their brand on it. And that's very important to us. CelFi Safe. Our products are absolutely safe. They don't interfere with each other. They don't interfere with other products on the network. You can layer them together. They're all intelligent, and they're not going to create problems for you. And then finally, perhaps the most important one is 100% peace of mind. With our equipment, there's no risk for the customer. There's no risk for the carrier. You can deploy these things confidently, and you can be assured that they're going to work, they're going to do what they say they do in our marketing material. Okay. So what are we talking about? We're talking about poor cellular coverage. It's a fact of life today. In the enterprise, 60 to 80% of workers experience poor coverage. That's a huge number. Of course, unacceptable in the enterprise setting, particularly when you realize that business processes are increasingly relying upon cellular coverage. And it's not just voice service. There's lots of other kinds of services that are being driven through mobile today. Of course, everybody knows this, but in the enterprise, it's absolutely critical that you have good coverage. For example, something that's becoming more and more common today is two-factor authentication. So if you're logging into something like your CRM system, like a Salesforce or SAP, or let's say you're doing some transaction on Amazon or even banking transactions, a lot of these transactions are using two-factor authentication, which means you're not only logging in, but it's sending you a message to your mobile that you have to either get a code or respond to, or you have to do something through your mobile device to prove that you are who you say you are. If you don't have coverage, you cannot do that. So it's not just for making phone calls anymore. It's a very important part of your business operation. So signal, what is good coverage? We talk a lot about good coverage. Maybe it's not that straightforward. In the world of 3G, it was a little bit easier to identify. You had RSSI. You could measure a number pretty quickly and understand is your coverage good or bad. With 4G LTE, it's a little bit different. There's a few different measurements that all kind of come together that will sort of indicate how good your coverage is or how bad your coverage is. And one thing I want to point out here, I hope you can see these numbers. I know it's a bit of an eye chart, but if you look at excellent coverage here says minus 90 dBm or better. And poor coverage is minus 20 dBm, right? Looking at the RSRP numbers. That's a 30 dB spread. So you have a 30 dB spread between excellent coverage and poor coverage. That 30 dB number you might recognize. That's the difference between us and most of our competition, 30 dB. It's a very important number. Decibel strength is incredibly important. 10 dB is 10x. So wherever you can gain or lose decibels, it's going to make a big difference to your footprint, to your performance. So keep those numbers in mind, difference between good and bad coverage. All right. This awesome graphic comes to us from our friends at Repeater Store. Smart buildings, smart cities. Of course, everybody's talking about that. It's a huge thing in the news. Everybody's trying to build out smart cities, smart buildings, and figure out what all that means. Well, one thing that means is for building materials is you're trying to improve energy efficiency. And one of the ways they do that is they put materials or films on the exterior of buildings that help keep the UV energy out of the building. Now, the problem with that is it also affects the cellular signal. So not only is it attenuating cellular signal coming into the building, but if you're inside the building and you've got a handset and you're trying to reach the tower on the outside, that building material is reflecting your signal back inside the building. So it's a sort of a two-way problem that you have to deal with. Okay. A little bit about attenuation. I'm sure there are many experts on this phone call who could lecture me on attenuation and how this works. This is a simple view. Just wanted to put this out there so we sort of have a framework for what we're talking about. So underneath the tower, you might have something like minus 25 dBm. Don't stand under a tower, by the way. And then over space, as that signal is transmitted over the air, you're going to lose power. If you're, say, 5,000 meters at 800 megahertz, you're going to lose probably 60 dB. So by the time that signal gets from the tower to your building, you're going to have a serious attenuation. You might be, say, at 85. Now, if you have a green building or a LEEDs compliant building or some sort of a film to make your building more efficient, or even if it's just concrete or covered in metal or whatever, you're going to have attenuation through the building. In this case, we're showing minus 30 dB, which is a rough estimate, but it's a common number that gets used for LEEDs compliant buildings is 30 dB. So you can see inside the building, you're minus 15 dBm. Minus 15 dBm, back to that to the coverage chart, is not good coverage. It's bad. So just one simple view of the physics behind coverage, and it doesn't matter which carrier. They're all the same. They're all using the same physics. It's quite difficult to put a good signal inside a building. Okay. So moving forward a little bit, talk a little bit about the market. Okay. So the market is, this is a familiar graphic to many of you probably. We see this all the time when we're talking about how cellular coverage is or how these buildings are stratified in the marketplace. At the top of this pyramid is what we'll call tier 1. These are buildings that are above 500,000 square feet, something like an airport, a stadium, a shopping center. This category of products has been served very well by DAS over time. And a lot of the familiar names in the DAS category do a great job of providing good cellular service to these sorts of facilities, and they've done so, and they will continue to. The bottom tier, tier 4, those are buildings or spaces that are under 25,000 square feet. Now remember, this is sort of industry standard terminology. A lot of the analysts and everybody sort of uses this chart when we're talking about this industry. So this tier 4 is under 25,000 square feet. And the middle two tiers is what we call the Middleprise. I wouldn't say that's a scientific term, but that's one that everybody's kind of adopted here when we're talking about what we're trying to do. So the middle two tiers, 25,000 square feet to about 500,000 square feet. Residential towers, commercial businesses, business parks, hotels, hospitals, retail, all of those things kind of become the Middleprise, and that's what we're really targeting with our systems. Okay. This is a requirements view. This view has two axes here, which I kind of like to use.
Hey, Joe,
yeah.
Can I just interrupt you? Could you go back to your last slide for a second?
Sure.
The question that came in from Bill was, where do Nextivity solutions fit into the overall solution space compared to small cells and signal boosters, for instance?
Okay, that's a great question. I think that we'll get more into the actual Nextivity solutions as we continue through this presentation. But what I would say is, if you're looking at this view, Nextivity historically we have essentially 5 product lines, 5 product categories, and we have a couple product categories that will address this lowest tier, the tier 4 solutions, smaller spaces up to 25,000 square feet. We've been building out those cellular coverage systems since day one here at Nextivity. We started in tier 4. So if you were to go to our website, for example, and look at our products, you'll see a number of products that really address the tier 4 pretty well. What I'm talking about today is QUATRA. That's our newest product add, and we'll talk more about that later in this presentation. But our QUATRA product has really been designed to focus on these middle two tiers, which we call the Middleprise. Okay. You asked also about small cells and some of the other solutions. I will talk about that. That will come up. Okay. So looking at the requirements view here, if you're trying to figure out the solutions in the cellular coverage space and sort of understand sort of how do I fit whatever solution into whatever requirement, this is a view that I like. We have technology on one axis and price on another. So if you look at the first axis, the technology, the highest requirements, the most technical requirements or the most performance requirements would be in the upper part of that, and the pricing for that technology is the highest, and that's sort of the upper right-hand corner. That's what we call big iron DAS. Many of you are probably familiar with that term. That's the top of the pyramid. Those are the solutions that do a really good job of delivering high capability, high capacity. You have a lot of capability that you can get with the big iron DAS systems. Now, of course, you pay for that and you wait for it. You have things like carrier contracts, redistribution agreements. You can have 90-day plus lead times for equipment. And many of you have probably had to work with the network operators and get contracts signed. That can be time consuming. These are huge organizations. There's a lot processing that happens there. So it's a complicated endeavor to try to deliver a solution at the top of that technology requirement. That's what the big iron DAS folks do pretty well. They're doing things like load balancing. They're running fiber backhaul, fiber front haul. They have CPRI controlled systems and a lot of stuff that you get at the top of that technology. Now on the bottom left-hand side, you have much less requirement for high tech. If you have a home, if you're deploying a cellular coverage system into a home or a small business, you don't need NMS, right? You're not going to need a network management system for that technology. You're not going to need alerts and alarms that your home smart booster or BDA or small cell or whatever you have isn't working. You don't need that kind of technology. You don't need fiber to your cellular system at home. You don't need all that power and scalability. But what we're saying is the Middleprise is right in the center of that. So you have some technology requirements. There are many elements of the cellular system that you'll need to deploy that the Middleprise wants. Middleprise wants NMS. They want to know, is my system working? And if it's not working, I want to know it. And they also have a certain price willingness to pay. The willingness is a little bit greater than what you have on the lower end of that system, but they're also not going to pay $5 a square foot to deploy, an all fiber, active DAS system in 200,000 square feet. It's overkill, and it just doesn't work for the Middleprise. So you have to sort of right size the requirements and the willingness to pay with the marketplace, and that's something I think we've done here. Okay, so what do they need? What does the Middleprise need? They need cellular coverage, right? That's what they need. They need cellular coverage. They need security and reliability. You try showing up at an enterprise or a Middleprise and asking them if you can plug something into their LAN. Not an easy process. Security is very important. Reliability is very important. From the smallest companies to the biggest companies, everybody's very concerned for security. What else do they need? They need manageability. You need quick reporting. Is my system working properly? If there's an issue, can it be diagnosed without somebody getting on an airplane or rolling a truck out? Truck rolls are $1,000 budget. So if you're an installer or you're an integrator and you've put a system into a small business or a mid-sized enterprise and you've got to get on a plane or drive a truck out there to figure out what's going on, you've eaten into your profits, and you don't want to do that. So you need manageability. The solution needs to be right-sized, right? If you have a 100,000 square foot warehouse that has 5 or 6 guys running around on forklifts in it, I don't think that's a capacity problem, right? You don't have 8 trillion terabytes flowing through that enterprise in that location. And keep in mind, the Cat5, your LAN that you've deployed, that's been deployed on 99% of enterprises. That's just my number. Don't quote me on that. But all of these data networks that are being run in business, they're all Cat5, right? So you have people showing up saying, well, you need to run a fiber backbone to your 100,000 square foot warehouse. Well, you should ask yourself, is that really needed? I mean, I have a data network there now. It seems to be working okay. I think probably your LAN is fine for your cellular needs in that location. Okay, the system needs to be simple. When you're thinking about what kind of a system you need for your Middleprise, do you want to install a telecom closet? Do you want to build a head-in? Do you want to build plenum risers and do all of that stuff that you need when you have a high capacity or a high demand for coverage or data throughput? So what you want to do is make sure your system is simple. It fits into your Middleprise space. It meets the needs of not only the company from a communication standpoint, but it fits into your physical layout of your building. You may not have a telecom closet. You may be challenged for space. Anyway, you want that system to meet your needs. And lastly, but definitely not least, is it needs to be operator friendly. The last thing you want is someone knocking on your door saying that the system that you put into your enterprise has brought down the network. Not only do you have legal liability with that, but you have other problems that it can generate, and most of them are not fun to deal with. So whatever you're doing, make sure your system is operator friendly. Okay, So what are the coverage options? This list hopefully is relatively familiar to everybody. Of course, I've talked about traditional DAS already. DAS, fantastic solution, done a great job, but it's too costly for the Middleprise. Like I said, a Middleprise just doesn't have the ROI, doesn't have the budget or the willingness to pay $4 or $5 a square foot for coverage. It's just not going to happen. So traditional DAS into the Middleprise is a tough one. Small cells, we love the marketing slicks behind the small cells. Fantastic value proposition. We hope that the vendors who make small cells and the carriers who deploy them get all of that sorted out properly to make it easy for customers. Our products are designed to work with small cells. I'll talk a little bit more about this later, but whatever we're using for a donor signal, whether it's a small cell or off air, our system functions equally with either one. So we're all behind small cells. Once small cells become widely adopted and affordable and usable and everything else. Wi-Fi calling, another great solution for enterprise, but it's an unmanaged service, right? It's best effort. It's great as a data layer underneath your mission critical services. Everybody uses Wi-Fi. We love Wi-Fi. It's great. If you're the VP of sales at a Middleprise, you don't want QoS problems, right? You don't want your call dropping. You don't want to miss calls. You don't want to have issues with your communications or your services to your handset. So, Wi-Fi calling, again, great service, but it's unmanaged. It's best effort. It's not mission critical. And of course, lastly, passive DAS. This is another product category, the final product category that's been applied in the Middleprise. It's fine. This is what we're displacing. This is the category we're disrupting. We're coming in and we're providing an active DAS style high performance solution in the Middleprise at a cost point that the Middleprise can swallow. Passive DAS systems have been a challenge to deploy. Performance is hit and miss. Highly skilled installers with the right sort of network environment can put in a system just fine. But some of them are challenged, and you end up with issues with the customer, reflects back on the industry, reflects back on the vendors, and we have lots of issues there. Passive DAS has lots of knobs, lots of dials. You have to have a high level of skill to make sure those systems are installed properly. And that's all opportunity for us. So we're going in with systems that we think are going to surpass those. All right. I have no idea how I'm doing on time here, but we'll plow forward. Okay, introducing. Yeah. Okay. Introducing Quatra. Okay. Cel-Fi QUATRA. It's a 3G, 4G LTE solution. It's friendly to operators and integrators. We have planning and aiming tools. I'll talk a little bit more about those. It's an all-digital Cat5e solution. What does that mean? That means you can run it across your LAN. You have Cat5 installed in your Middleprise today, wire it up. If you don't, I think if you can install an access point, you can run Cat5 cable and you can make our systems work. We even had our marketing guy install a Quatra system. So I think he did that in under 30 minutes. So very, very simple. I've talked about gain. Our systems are 100 dB gain. We're up from a competitive sense, we're up against products that can be 70 dB gain or at the most 80 dB gain in our category. Now, I told you a little about coverage and how gain is measured, how coverage is measured, and how important that those numbers are. If we're 20 or 30 dB better than the competition, you can understand what sort of an impact that makes on the product and on the footprint itself. Our products can work with a small cell. We call that Supercell Mode. You can be tethered to a small cell. Any small cell. We've tested with small cells from AT&T, from Verizon, from some European carriers. We've tested with all kinds of small cells. Small cell is a great donor signal for the Cel-Fi QUATRA. Happy to use it. Or you can go off air, run some antennas up to the roof, wire them up to our NU, which I'll talk about, and you're up and running with the system very, very quickly. We have an NMS system. It's all driven by it's all underneath our Wave, our cloud, which we call Wave. NMS is super easy. It's an IFTTT style interface, so very simple to set up new users, set up alerts, set up alarms. You can have alerts and alarms go to the IT administrator or to the integrator or to both or whatever. Super easy, very flexible, and it's all part of our Quatra value proposition. It's not something separate that you have to go out and pay for or install or get running. It's all part of it. And then finally, our systems are deployed in hours. You don't need any contracts, don't need sign-off, you don't need redistribution agreements, you don't have to call anybody. We are fully certified, we're FCC certified, we're CE certified, we've gotten every certification we can get in whatever region we're selling in. It's very simple, they can be deployed in hours. All of our partners have gear, you can make a phone call and have stuff show up the next day. All right. So again, looking at how Quatra fits into the matrix that I showed you before, the graphic I showed you before, we're right in the middle. So Cel-Fi QUATRA has been designed to serve the needs of this requirement. We have enough technology, we have enough capacity, enough capability built into this product to hit right the center of that need, which is right in the middle of where the Middleprise is. And it's all delivered at a cost point that is acceptable to the Middleprise. It's an ROI that they can make sense of. Less sticker shock, less reluctance to install, and you can get a calculation where it makes a lot of sense for the customer. They can put in a system and they can say, look, cellular coverage, good cellular coverage is worth it to me to pay this much. And with the Cel-Fi QUATRA system, you're right into that, right into the center of that value proposition. Okay. So.
Hey, Joe?
Yes.
Another question just came in. Can you talk a little bit why echo cancellation is so important? Sure.
So when you're deploying systems, I'm going to try to simplify this so it's not a 45-minute answer. But when you're deploying coverage systems, you're going to be putting out nodes that radiate. Those are, in some systems they call them remotes. In a passive system, that would be your antenna or your coverage antenna. In our parlance, we call it the coverage unit or CU. But essentially, they're all sort of the same thing. They're all nodes that radiate your coverage, and they communicate with your UEs or your phones underneath the coverage bubble. So when you're deploying a system with a bunch of nodes trying to create a coverage footprint, obviously these buildings are not perfect circles or they're not squares, so you're going to have to deploy coverage nodes in a way that there could be some overlap. You may have a concrete wall, so you've got two nodes on each side of that concrete wall, and you might have some signal bleed through, or you have signal that's getting on top of each other. Well, if you don't have echo cancellation, what's going to happen is you have these nodes are interfering with each other, and they're interfering with your signal source. So I have a radiating point that's coming back into my donor point. And if you have a sort of a dumb system that doesn't know how to handle that, how to handle those signals, that can't recognize that signal for what it is. In other words, I can't differentiate between my donor signal and my coverage node signal, then I'm going to have what's called echo. And that can create bad problems for in-building systems. It can create oscillation. The other thing you can do is reduce your power. So if you have a reduction in power, then you have a reduction in your footprint. So with an intelligent echo cancellation like we have with Quatra, we have the ability to discern our own signals and prevent them from interfering with one another. What does that mean for the installer? What it means for the installer is it's really simple to install these things. You can spread out the coverage nodes in a way that makes sense for your coverage footprint, and you don't have to worry about too much interference or too much oscillation or echoing happening in that system. So it makes it easier for the installer. It also makes a better coverage experience for the user because you don't have issues where you're shrinking your power or reducing your coverage footprint. So echo cancellation is super important. We spend a lot of we have a lot of IP in echo cancellation. We spend a lot of time building echo cancellation algorithms and things into our products so that we can provide the best customer experience. In fact, we've gotten to the point now with our echo cancellation where we can actually have positive margins on echo, which means you have circles of coverage that can overlap each other better without interfering. Whereas in traditional systems, you sort of have your coverage footprints, and you really don't want them on top of each other too much, because you're going to have issues. But with ours, we've really developed some technology that makes our echo cancellation really strong. Okay. So, yeah, I talked about that one. Multi-operator systems comparison. So passive DAS or BDA systems, what is the difference here with the Quatra? If you look at the top system here with a BDA, what a BDA is essentially a wideband booster. And what it does is it takes all of its incoming signals, and it does some measurements in terms of power of those signals, and it provides a boost level over coax to the systems on the end. And the challenge with a wideband BDA is you have a variety of incoming signals. So on our graph, we have 4 carriers that are coming into these products. With a BDA, you're going to get a certain amount of gain, and it's going to put that gain across your systems, and it's going to apply that gain equally. So what does it mean on the ground is if you've got a strong carrier signal from carrier A and a weak signal from carrier B, you're going to have a different coverage footprint from those carriers in your space. And that's because they've been boosted differently. With CelFi, with Quatra, what we do is each carrier is boosted independently. So we measure the inbound signal from each carrier, and we apply a maximum boost to deliver maximum power at the coverage node. So it's what you get is a uniform power distribution. You get uniform coverage for all carriers. If you have a weak inbound signal, we're going to boost that more. And with 100 dB of gain, we have a lot of headroom where we can really provide a lot of power and get you to full power at the coverage unit. If you already have a strong inbound signal, we don't have to boost that one as much. So, and we can do all of that intelligently, all of that across our Cat5 cable. You stick that signal into a single coverage unit, and you get an awesome experience on the end. And it's all done in a lossless manner. So again, it's just Ethernet cable. It's Cat5 cable. If you can install an access point, you can install a Cel-Fi QUATRA. Okay. So scalability. This is an important one for us. Remember, the Middleprise is 25,000 square feet to 500,000 square feet. So it's not a one-size-fits-all type of a marketplace. There's a lot of different requirements, a lot of different needs, and difficult to find a solution that can scale to meet all of those. So there's 3 ways that you can implement Quatra. The first way I mentioned is with a small cell with a supercell. Okay. Second way is off-air with a single carrier. So if you've got a problem that you have a single carrier problem, or maybe you have a corporate liable type enterprise, you have an enterprise that has 50 users all with the same carrier, you can deploy a single carrier system. If you've got a public space or a BYOD environment, an enterprise that's got a lot of different things going inside, you can employ a multi-carrier Quatra solution. It's very simple to calculate. As I mentioned, we have NUs and CUs. Each one of our NUs can support up to 4 CUs. So one NU will deliver about 50,000 square feet of coverage. If you have larger space, you simply deploy more NUs. You can layer them on top of each other. You can, it's highly scalable. You can switch the number of CUs you have for your coverage footprint. It's extremely easy to build a system that scales with Quatra. Just simply layer the NUs. It's really simple. Okay. Supercell mode. Talked a little bit about small cells. Again, we love small cells. They're super cool. You're getting capacity when you're using a small cell. There's a lot of flexibility that's offered with them. One of the challenges, this is probably a tough illustration to see in this kind of a context, but if you notice, the small cell in the upper left is deployed right in the middle, so you get a really strong coverage with the small cell in that area. But you'll notice that around the perimeter, you will have issues. And most buildings are not open boxes. They have internal structures that create challenges for small cells. You have offices, you have cubes, risers, elevator shafts, closets, you have lots of concrete, multiple stories. So it's difficult to have a uniform distribution with a small cell. If you attach, or if you deploy Quatra in a Supercell mode, then you can use a small cell for your donor source, but then deploy these coverage nodes throughout your building that give you a really strong uniform coverage footprint throughout the interior of your space. The other thing that does is you get a uniform QoS experience, and you've solved the dominance problem. And what the dominance problem is you have external cellular signals right through your macros, through the cells that are outside of your building. And then if you have a small cell inside the building, your user equipment is it can get into a mode where it's hopping between connecting to the macro on the outside to connecting to the small cell on the inside. That problem is called dominance. And if you have an area where the dominance is sort of questionable, your UE can hop around and it can create a poor user experience. If you deploy Quatra in a Supercell mode, we've solved that. So wherever you are inside the building, you've got a strong pilot signal from the small cell, and you have a good user experience. When you exit the building, you attach to the macro, and everybody's happy.
Hey, Joe.
Yeah.
Just had another question from one of our listeners, and what they ask is, why would I buy a CelFi type solution when I can buy a small cell that utilizes my enterprise internet connection to connect to the cellular network, and I don't need to install an antenna on the roof?
Well, that's a good question. Part of it, I think, I just sort of addressed. A small cell, again, will give you a coverage, will give you a good coverage solution in a single point. Now, if you have let's say you have a 25 or a 20,000 square foot space, and your company sort of looks like a large box, and you have a bunch of low hanging or low cubes, so you have a real big open space and not a bunch of stuff on the interior. It's a smaller space. Sure, you could put a small cell in the middle of that and it would radiate and you'd be fine. But what we find is that most of the enterprises where we're installing, you have a lot of RF structural things that you have to deal with that affect the propagation inside your building. So if you install a small cell in the center of your building or in the center of your space, you're going to have a lot of issues with other parts of your space, whether it's offices or a different floor or behind a concrete wall or in the kitchen, in the conference room, or whatever. It's a propagation issue. So you won't have a uniform propagation with the small cell. And this is all done for us. It's all done with experience, right? We go out on site, we measure this stuff. We work with customers who have deployed small cells. Some of them they work great. Some of them they've had issues. So our position is we love working with the small cell as a donor source, but what we can add to that equation is a really good distribution of the signal. And
okay. Thanks. I appreciate it. And I wanted to make sure that everybody understood that if we're using small cell as a feeder, that we don't actually have to have an antenna, an external antenna in that scenario. The small cell replaces the external antenna.
Oh, yeah. Thank you,
Having said that, Joe, we're running a little bit behind, so
okay.
I'll let you know.
Okay, great. I'll speed up a little bit. So these are the components of Quatra. Very, very simple. You have the NU on the upper left. This is also, some people refer to this as the head end, although it's about that big. So I don't know if a head end is the right thing to call it. It's a small piece of equipment, sort of more like an access point or a modem. On the right are our CUs. They are literally about the size of an access point. They're all power over Ethernet. Bolt them to the wall, plug in your LAN cable, and you're operational. Okay. This is our Quatra range extender. Our standard equipment from the NU to the CU can run at 100 meters without any issue. If you want to go beyond 100 meters, you can go up to 200 meters. You just simply put this device in the middle. So it's not powered. You don't need to do anything other than plug the LAN in on one side and out on the other side, and now you have a 200-meter range. Okay. This is our small cell interface in the center. On the bottom is a small cell, and on the top is our NU. So if you are connecting a small cell to our NU as a donor, all you have to do is simply use our small cell interface in the middle. It does a good job of cable management and sort of routing the system, so you don't have to think too much. It also attenuates the small cell signal to a level that the NU expects from the donor. Very, very simple. This setup is, again, it's 15 minutes to do, and there's no dials, there's no knobs, there's nothing to do other than connect these wires. Super simple. We've been built for the installer. When we approached this market, we wanted to disrupt this. Not only the equipment, but also building the tools and the support around around Cel-Fi QUATRA that can make this thing accessible for our partners and for the customers for that experience. It's the easiest to deploy in the market. We have a bunch of things that we're providing to our partners to make this easier. We have a BOM estimator tool. We have IB Wave templates available for download. You can go to our website and get those immediately. They're available to our partners and customers. Everything we do is all digital. We have Antenna Boost, which is I'll talk about it a little bit in a second, and then of course our Wave platform, which provides our sort of our MMS and our cloud connectivity to all of our endpoints. This is our estimator tool. It's very, very simple. Many of you are familiar with IB Wave. IB Wave is a great tool. You need to do a sophisticated site survey and provide a sort of a view of the coverage there. We have something that works well in that scenario. This is all available via the web. It's a BOM estimator tool. What this will do is sort of help you understand what your equipment needs are for that site. And you can use this as a pre-sale capability or post-sale, however it meets your business need. It's all the modeling here is IEEE based on RF propagation models that are all sort of industry standard, the same ones that other tools, very expensive tools, use. So you can get a very sort of a quick view on what you need on site. Wave, talk a little bit about that. This is our Wave portal. It runs our NMS. We're in San Diego, so we like waves. We like ocean waves. We like radio waves. We like all waves. So this is our cloud we call Wave. This drives everything that we do from a software standpoint. Antenna Boost is this is our our donor signal aiming application. Again, it's free for all of our partners. Very simple to use. With this application and running with our cloud, we have algorithms that will help you determine what the best positioning is of your donor antenna. It's super simple. Takes one person and a mobile app to use. And in a matter of minutes, you can have your donor signal aimed perfectly. We have a custom-built mount that we supply that you can literally lock the antenna down into position very simply, and you're done aiming your signal, and you're ready to go. Okay? So talking a little bit about our customers, talking about the Middleprise here, we're absolutely targeting the Middleprise. What we found in terms of usage and customer experience thus far, we've been shipping for about a year now. So we're finding that hospitals, hospitality, government, and contractors are sort of our top markets. And we have other deployments in many of these other ones that you see listed there. We sort of group those together as offices, manufacturing, warehouses, and parking garages. So talking a little bit of...
Joe,
yeah.
One more real quick. Do you anticipate, customer David Gibson wants to know if we anticipate participating in public safety systems in the future?
Yes, great question. Absolutely. We are going to disrupt public safety the same way we have disrupted the residential BDA category, and we're disrupting the Middleprise. We are going to be in public safety. We have a lot of stuff we're working on now. I can't get into the details, but stand by. If you love what we deliver as Nextivity under the CelFi brand, if you like simple to use, simple to install, if you like all digital systems, if you like systems that run over Cat5 cable versus coax or fiber, if you like all of those things, you're going to like what we're doing in public safety. I would invite everybody to contact me or communicate with me or with your sales lead and keep up to speed on that. We have a lot to do there. Okay, so quick use case here. I'm just going to go through a few of these. Just help you understand what we're doing. This was a 10-story, 375,000 square foot apartment building. They had serious cellular problems, concrete ceilings. None of the services inside the building worked very well. This particular building owner was actually losing customers. People would walk in, turn on their phone, can't make a phone call, and they walk out. They're saying cellular is the fourth utility. Absolutely applied in this case. We asked this guy to make a phone call once the system had been installed, and initially he said no, but he made a phone call. It was the first time he'd been able to make a call in his apartment. Here's another one, hospital. This was one where the issue was they had AT&T service into one of their labs. They had some existing equipment that just it didn't work properly. It wasn't enough for the customer. The customer was not delighted. The system wasn't high powered enough, honestly. It didn't work. So afterwards, of course, it worked great. And the customer and the integrator had peace of mind. System works well. Everybody left happy on that one. Oil and gas. This was a 40,000 square foot new space. They had deployed sort of a BDA-based DAS solution. Didn't work well for them. Service was spotty. It was they were having issues with employees. Employees were dropping calls. They were getting POS issues, jitter, warble, whatever. It was a bad user experience inside the building. We went in and put Quatra in, single donor antenna, and it lit up the building. Everybody was happy. Sales guy could sell stuff, and the company is now conquering the world. Hospitality. So this was a use case where we had a hotel. They had 2 sub-basement floors. Again, a BDA-based DAS solution. It just couldn't. It didn't service the basement floors very well. We put in a Quatra. The quote on the bottom there was from one of our installers. He said, the Cel-Fi QUATRA is a game changer. We believe that too. We hope you'll join us and find out for yourself. Okay, final use case. This was a little bit larger one. This was a 376,000 square foot plant. It was very rural. The signal was already not great. This was a very large facility with a high roof, had a metal roof, and they just really had very poor signal inside the building, which was affecting operations. The logistics and operations of this company was affected by lack of cell coverage. We were able to put in a Quatra system into this space. I think they used several NUs, put a nice covered footprint into the space. And they said not only did we cover more square footage, but they actually had a better signal inside the building than outside of the big building when we were done. So another happy customer. And with that, I will wrap up. Thank you, everyone, for being on this. I think if we have a little time, maybe a couple of questions.
Yeah, Joe, that would be great, actually. We have had a couple of questions. One of the ones that just came up is there a limitation to the number of simultaneous users you can have on a CelFi system?
Well, there's no limitation. That's a great question. It's very difficult to answer because there's no standard for what a user is. There's a huge variety of how users use their phone. And if you've got 14 teenagers and they're all on YouTube downloading video in real time in a single closet-sized room, you're going to tax any system. What we have found in real life, and I personally have been with Nextivity for a little over 4 years, and have been delivering CelFi systems for that entire time. In that entire 4-year period, we've only had one situation where we felt like the number of users was exceeded. It was the what do you call it? The concierge room in an airport. And so it had a huge number of users, all business travelers, on their phone all at the same time in a very small space. That was a single time that in my 4 years where we felt like the capacity was exceeded from our system. Deploying thousands, hundreds of thousands of systems over the last 10 years, I don't think we've run into user limitations from our stuff. I don't know if that's the that's the best answer, but that's the answer that I have.
Okay.
Anything else?
Joe, we've actually, Dean and I have been sitting here feverishly answering questions because we knew you had a lot of information to go through.
Obviously, if anybody on the line would like to become a partner or buy Quatra, we've got a couple of links there for them. We've had a lot of questions on individual use cases. Our sales team would happily go over that information individually with folks. Just ping us with your best contact information. We'll get back with you.
And the other thing worth noting is a lot of people have asked, can we get a copy of the slides? Can we get a copy of the presentation? We will make this presentation available on our website in the next couple of days. And we'll send out a link to everybody that was involved in the webinar. We'll just send out a broadcast email that gives you the URL for the presentation. If you are a Nextivity partner and you'd like to get a copy of the slide deck, just email us and we will be able to get that out to you.
Okay.
Joe, did you have fun?
Yeah, thanks everybody. I hope it was okay.
Okay, I think we did great. Thank you everybody for attending. We had a nice robust attendance and the vast majority of people stayed with us right up till the end. So appreciate you being involved. Joe, thank you again. And we will look forward to seeing you all for the next webinar.
All right.
Okay, bye-bye.
Thank you.